All right, hello there, students. In this video, we're going to talk about quadratic and cubic inequalities. So we're going to start here with a quadratic inequality. And the first thing we're going to do is we're going to set those factors equal to 0. So we're going to basically solve the corresponding equation. And let me go ahead and do that, and then I'll tell you why we're going to do that. So I'm going to set each of the factors equal to 0 and solve. When I solve this equation, I get x equals 3 over 2. When I solve this equation, I get x equals negative 5. The reason why we want to solve the corresponding equation, oh wow, that line's not very straight, is it? Is because these are the only two numbers at which this inequality could change sign from positive to negative or negative to positive. And so by solving the corresponding equation, you're going to get the numbers at which the inequality could change sign. Now I'm going to put my numbers on a number line. Make sure you put them in numerical order. Since negative 5 is smaller than 3 over 2, we want to make sure negative 5 is to the left of 3 over 2. And these two numbers here split our number line into 3 intervals. And I'm going to use a sign chart to help me to finish this problem. So in my sign chart here at the top, I'm going to write the 3 intervals. So our first interval is negative infinity to negative 5. Negative infinity is used to represent a really small number. Then our middle interval is from negative 5 to 3 over 2. And our final interval, our third interval, is from 3 over 2 to infinity. Now also in my sign chart, I'm going to write the factors from the inequality. So 2x minus 3 and x plus 5. Now I'm going to pick a number in each of my intervals, and I'm going to plug those numbers into the factors. And really all I'm concerned about is whether I get a positive or a negative result. Now I could pick any number I want in each interval. So how about I pick negative 6. I need to pick a number that's less than negative 5. So how about negative 6? I need to pick a number between negative 5 and 3 over 2. How about 0? 0 is always easy to plug in if 0 falls in a certain interval. And then our final interval, I got to pick something bigger than 3 over 2. 3 halves is 1.5. So how about I pick 2? So I'm going to plug these numbers into the factors. And as I mentioned before, all I'm concerned about is whether I get a negative or a positive result. When we plug negative 6 into this factor, we end up getting, it's really negative 15, but that doesn't really matter. All I care about is that I get a negative result. When I plug negative 6 into this factor, I also get a negative result. If this factor is negative and this factor is negative, a negative times a negative is a positive. So when negative 6 gets plugged into the inequality, we get a positive result, which means if you look at the original inequality symbol, we're looking for less than 0. So negative 6 is not part of our solution set. So negative 6 is not part of our solution set. That also means that no number in that interval will be part of our solution set, because the only two numbers at which this inequality could change sign is negative 5 and 3 over 2. So if negative 6 doesn't work in the inequality, no number less than negative 5 is going to work in the inequality. Now let's test 0. If I plug 0 into the first factor, I get a negative result. If I plug 0 into the second factor, I get a positive result. A negative times a positive is a negative. Now that's good, because we are looking for, if you look at our original inequality, we are looking for results to be less than 0. So 0 satisfies the inequality. That also means that every number in this interval will satisfy the inequality. Every number in between -5 and 3/2 would give us a negative plugged in when we plug into the first factor and a positive when we plug into the second factor. All right, and then finally 2, plugging 2 in gives us a positive result in the first factor. Plugging 2 into the second factor, also a positive result. A positive times a positive is positive. Okay, no numbers in this interval will satisfy the inequality. 2 did not work, and so nothing in that interval will work. Our final solution set, would be the interval from -5 to 3/2. When I write in interval notation, I'm going to use parentheses, because when x equals -5, we would get a result of 0, which would not be less than 0. Same thing with 3/2. You get 0, which is not less than 0. So we're going to use parentheses because our inequality symbol is a less than symbol. All right, let's look at another quadratic inequality. This one is going to be very similar to the last example, except that we are going to have to factor before we can set up our sign chart. So we're looking for two numbers that add to -7 and multiply to 10. Those two numbers would be -5 and -2. So I can factor this trinomial on the left-hand side of this inequality into x minus 5 times the quantity x minus 2. Just as I did with the last problem, I'm going to solve the corresponding equation, and I'm going to plot the two solutions that I get on a number line. When I solve, I get that x equals 5 or 2. I'm going to plot those points on a number line. Got to make sure I put them in numerical order. 2 is smaller than 5, so it's going to go to the left of 5. And these two numbers, when plotted on the number line, they split our number line into 3 separate intervals. Those intervals are -∞ to 2. Now this time I'm going to use brackets because of the inequality symbol being a greater than or equal to. So at 2 and at 5, or if I plug in 2 and if I plug in 5, I will get 0. But 0 is greater than or equal to 0. So those are going to be 2 and 5 will be part of our solution set. The next interval is 2 to 5, and our final interval would be 5 to infinity. I'm also in my sign chart going to enter my factors. Okay, and then I'm going to choose a number in each interval to test or plug into the factors. So I need to pick a number less than 2. How about 0? I mentioned 0 is always a nice one to plug in. I need to plug in a number between 2 and 5. How about 3? And I need to plug in a number bigger than 5. How about 6? When I plug 0 into the first factor, I get a negative result. When I plug 0 into the second factor, I get a negative result. A negative times a negative is a positive. Now looking at my inequality symbol in this problem, it's a greater than or equal to. So this interval will be part of my solution set because I'm looking for this product to be greater than or equal to 0, and I got a positive result. that means that every number in this interval is part of the solution set. If 0 turned out a positive result, every number in this interval will be positive when plugged into the trinomial on the left-hand side. 3 gives us a negative result, but then a positive result. A negative times a positive is negative. This interval will not be in our solution set because we're looking for this product to be greater than or equal to 0. 6 gives us a positive result and a positive result. A positive times a positive is a positive. Also works. All right, so numbers in this interval will be part of our solution set. So our solution set written in interval notation will look like this. And we have successfully solved this quadratic inequality. Okay, we've got one more left for this video, and it's a cubic inequality. To factor this is going to be a little tougher, but then the process is going to be the same process that we've been following thus far. So I'm going to factor by grouping. I'm going to factor out a GCF from terms 1 and 2, and I would have 2x plus 3 left. I'm going to factor out a GCF from terms 3 and 4, and the GCF, I need to use -9 because I want the same expression inside the parentheses. And so if I factor out a -9, I would also be left with 2x plus 3 again. It would be 2x plus 3, even though this is a -27, when you factor out a -9, it is going to change that sign and make it +3. Okay, then I've got two factors here, x squared minus 9 and 2x plus 3. And I just want to real quick point out that, remember, you can always check to make sure you factored correctly. You can FOIL here at this step. When you FOIL, you will get back to this 2x cubed plus 3x squared minus 18x minus 27. So 2x cubed plus 3x squared minus 18x minus 27. So we can see by FOILing here that we did correctly factor. But we can factor one more time here. We have a difference of squares. So I'm going to go ahead and break this down further into x plus 3 times the quantity x minus 3. Now, just as we've done in the last two examples, I'm going to solve the corresponding equation, and then I will plot on my number line these three numbers that I get. So when I solve the first equation, I get x equals -3. Then I get x equals 3. And then over here we have -3/2. So these three numbers are going to get plotted on my number line. Once again, I need to put them in numerical order. -3 is the smallest. -3/2 comes next. And then 3 is the biggest. These are the only three numbers at which this inequality could change sign. So they're important. They split our number line into, this time, 4 different intervals. So we've got the interval -infinity to -3. Then we have -3 to 3/2, -3/2. Then we have -3/2 to 3. And then our final interval is 3 to infinity. I'm using brackets again in this problem because my inequality symbol is a less than or equal to. So -3, -3/2, and 3 are going to be part of our solution set, since when plugged in, they will equal 0, but 0 is less than or equal to 0. Okay, over here, I'm going to put my three factors. And I'm going to choose a number in each interval to plug in. to my factors. So I need a number that is less than -3. How about -4? I need a number in between here. How about -2? Now this is -1.5, so -2 would fall in that interval. I need a number between -3/2 and 3. How about 0? 0 is nice to plug in. And a number bigger than 3, how about 4? When I plug -4 into the first factor, I get a negative result. When I plug it into the second factor, I get a negative result. And when I plug it into the third factor, I get a negative result. A negative times a negative times a negative is negative. Okay, if I have 3 negative results, when you take the product of 3 negative numbers, the result is negative. Now, I'll put a little smiley face here. This is good because my inequality symbol is a less than or equal to. So I am looking for a negative result or a result of 0, which happens at these 3 numbers. All right, -2. When plugged into the first factor, I get a positive result. Second factor, negative result. Third factor, negative result. This is going to end up being positive because 2 negatives multiplied together is a positive, and a positive times a positive is positive. 0 would be positive, negative, positive, which is going to give me a negative result. A positive times a negative is negative, and a negative times a positive is also negative. So this is also going to be part of our solution set. In fact, I can start graphing over here if I want. You don't have to make the graph, but I feel like it's helpful. And then finally, when you plug in 4, you get positive, positive, positive. 3 positive numbers multiplied together gives you a positive result. Our final answer here will be -infinity to -3, along with the interval -3/2 to 3. So this is our solution set. And before stopping this video, I just want to remind you one more time that we only need to test one number because every number in these intervals will behave the same when plugged into the factors. So it's only necessary to check just one number. The only 3 numbers at which this inequality could change sign are plotted on our number line. So within the intervals, the numbers behave the same. All right, I hope you found this video helpful. There will be, or there is, another video on rational inequalities. So if you need more help with inequalities, check that video out.